As Mike said, I am Daniel, and today I will show you what is and how achieve dependency injection in Go. Keep in mind that this presentation is targeted for the beginners and intermediate level. So if anyone knows much more about that, so please don't fall asleep during my presentation. And there will be code on the slide, so it will only be as a background for what I'm trying to say, and the code along with the presentation I will publish in comments to this GoWroc meeting. And I would like to start with an ugly code example to show you more of a journey from this to something better. And in this example, I've made a few mistakes deliberately. The first one is to use global variable and init for initialization connection to the database. And the functions are pretty okay to fetch data from database. Some basic handlers to fetch the data and serialize it to the response. And a main function that simply registers the handlers to the default max and run the HTTP server. Now, what are the dependencies? And dependencies, in short, are components that in Go, mostly structs, that are required by our code, our current code. Well, more or less, it's a dependency that it's a component that requires some components to work. And dependencies might be quite problematic to identify in our applications. In general, we tend to use some architecture patterns like clean architecture, hex architecture to help us with identifying dependencies, and of course a bit of common sense, because no pattern is clever enough to solve all our problems. And in this example, in this presentation, I will more or less follow clean architecture, and I will show you some repository easy example of repository and service that we interact with it. And here is a bit cleaner state. Bit cleaner state because I've identified some dependencies. Here's the state repository, and as you can see, yeah, I forgot the struct for this one, but you can imagine there's also a struct before that, and which consists of two methods. One is to fetch entries, and one is to fetch single entry. And it also creates a connection to the database within a construction. Here's a block service that basically creates a new repository, and as well, similarly, just got a list and get methods. And simple HTTP handler, which returns a max that we will use later on, and register two methods that didn't fit to the code, but they're basically the same as in the ugly example. And also pretty pretty easy main function that simply creates a new handler instance and servers this server in HTTP server. So the problems with this approach is that there are a few problems with this approach. Is that everything is tightly coded. Our components initially creates components that they are required. And in that example, it's not a problem because we use only one connection to the database, one repository. It's quite easy. But in the real-world applications, where we got plenty of repositories and so on, essentially it creates a connection to the database. There is it's not a very elegant solution. And it's difficult to test. And because to test it, we have to test everything in one place. And it also requires a database to run it. And it will open a port. And basically what we will do trying to test that is more of integration test. Problematic to change dependencies. For example, well, it's better than in the first example where the code is looks more like a spaghetti code, where the database is used directly by database connection is directly used by the function that fetches data from it. But even with this a little bit cleaner state, it would require plenty of hand changes in the code. And low overall maintainability is more of a result of the previous bullets. What is dependency injection? Generally short, dependency injection is putting components that are required into another component. So basically, instead of creating dependencies like the database connection or repository, we just pass them from outer code, outer scope. And the dependencies itself should have no code to create any of its dependencies. In the first place, to inject dependencies, we have a place to store it. And basically, for this reason, we use fields in abstract. And yes, we use fields in abstract. And injection can be done in two ways. First is upon creation of this struct, or using by a setter. Using a setter for this it might be error prone, as we can forget to call a setter. So the best solution is to inject dependencies upon creation. And again, there are two ways to do it. First is by the struct composition, and the second way is by a so-called constructor new function. The second one is more preferred because of two reasons. Again, the first one is that function we won't compile code that we forgot to insert some dependencies but with struct composition, we simply can forget about some dependencies. And the second reason why the constructor is better option is because we can do some more initialization than only returning a simple struct. For example, like mapping initialization is the reason the purpose I usually use. And nevertheless, even for this very simple reason, I strongly advise to use construction functions. Okay. So now, having the previous knowledge in place, the refactor itself for this repository is pretty minor. As you can see, I removed the code responsible for creation of database connection, and simply I pass it to the repository constructor. Here, for the block service, is a little bit more changes. Not only I pass this post repository, but there's also this use of interfaces. It's what's most important here is that is how Go uses interfaces. Because of implicit declaration of interfaces, which means that interface is fulfilled not by telling I will implement this interface, but when I implement given methods, I can simply write my interface that I will require in this given context simply in this package. And I will show example how this is good in few more slides. And what's for me very good is that by this we can achieve almost ideal form of loose copying, because in other languages this repository interface must be found somewhere, and usually, at least from my experience, is the same place where the repository lives. And take for example, if somehow we find somewhere a code that fulfills this interface, we can simply use it right away. In other languages like Java and C#, we are forced to use somehow some adapter just to use it here, despite having the same signature. Yes, and using interfaces or in general abstractions satisfies dependency injection principle, which means that the higher level components doesn't depend on low level dependencies. In this way, the stress block service is not aware of repository more than it needs to be. It needs to have two methods, and where this repository is, where it stores data, it's up to developer or up to repository. And similar changes are here to the HTTP handler. On the side note, it's not the not the best code. Maybe this part you shouldn't take too seriously. But I didn't want to write another layer of abstraction to be more up to clean architecture. And this is the only downside of manual wiring, so-called manual wiring in Go, is the fact that in your main file you will have to instantiate plenty of dependencies and simply put one into another like matryoshka. But it does have one significant plus. If, for example, you would change any of the signature, like it will be changed in the one of the interfaces or one of the constructors, most of the EDAs of our editors will simply highlight what's wrong with that. And well, personally, for me, is the only one of the justification for this one. And what the dependency injection give us? And now that's mostly it solves the problems I highlighted before. In terms of unit testing, the dependency injection approach, the test itself starts to begin easier. Simpler. Because now we can focus on testing one thing at a time. And because on previous scenarios, as I said, we are forced to test everything at once, which could have potential problems. And here to test a block repository, we create a struct that will is as a mock repository. It's quite simple. It simply returns the data we just passed to it, and now here like it should looks in our simple test, where the mock repository for get entry will always return a post with ID 12 till title 12 and so on. Now we put this mocked post repository into our block service and call get 16. I deliberately made that, and the output is very predictable in this case, as it should be. And yes, that's for testing. Maintainability, more of extendability in this particular scenario. Let's say that in our simple block application we want to also include information about author. Normally it could also be done by changing the SQL, but this is only for the sake of presentation. So I wrote the author repository interface, quite simple, with only method gets that will return information about the author. And now in the block service, and of course it's the repository itself is passed to the block service by constructor, and the block service gets uses this author repository. It's easy example, so it's in this easy way. But it simplifies work in larger application. Replacing the dependencies. Quite similar story to what I said before, but this time we already have our interface in block service. So what's only needed here is to write a new new repository that simply utilizes the Redis client and have all the same functions that are methods that are required. And in mine, the main difference is that we replace the open database with OpenRedis function, and basically we just pass the new repository into our blog service. And basically that's all. It's even better if you have plenty of services, other stuff, because otherwise you will have to manually change the creation of the new Redis repository everywhere in the code. For example, if you use this 10 times, so 10 times you will have to change it. Yes. Okay. So I called it time now problem because it's a function that I come across most commonly. What's the problem? The problem is just the function in the external package. We cannot mock it because it's a function. If it were a function that were assigned to a variable, we could simply replace that, despite it's not an elegant way to do testing. And everything goes to its difficulty tests. Because let's imagine we are saving some information to database and we want to have data time, not of our database, but the time of from the server we were calling this function. We could do something like check if the output of this is within the range like now minus 1 minute. It could work, right? But it's a little bit ugly solution. And what's more important is that it hits more if we have a call to external API, which is a really bad idea to have a call to an external API within our unit tests. So the solution is quite simple. It's just to use this function as a dependency. And thanks to the fact that in GoWroc, functions are first-class citizens, which means not only we can return and pass it to a function, we can also assign them to a field in abstract. And here we are kind of forced to use this new repository because we have to assign time now to this now function for normal use. But in the tests, we can simply have this function returns always the same time. So basically, in the end, it will be just compare some. Given the example with saying that something to the database, we simply compare a query to a query that is expected, and that's all. And this way we have predictable output. Yes, I put those. The last two topics I want to speak about are the dependency injection containers and frameworks. I'm not a fan of them. To be honest, I learned about them just this weekend to have this presentation more complete, and be fair to also those who are fans of this kind of solutions. I'm not a fan, and I think, at least from what I see in Go community, it seems to be a consensus that we don't use containers or frameworks, because GoWroc seems to be a bit too simple language to have such complicated stuff within. It's more like newcomers from other languages like Java or C# looks for known patterns to them and leans towards this kind of stuff. And the containers. Don't quote me for that. This might be just my imagination how containers should look alike. But basically, containers are a place from where you can reach and take a dependency that you need in given situation. Like, and this container will be the only one dependency that will be passed to the repositories, services, and so on. And within it, we simply do a call to container for getDB and use it this way. The problem with this approach is that it doesn't seem very elegant, and it kind of violates the single responsibility principle, because okay, one can say that this is responsibility for creation of things, but also, from the other hand, it also creates different kind of things, and this seems to be a small contradiction. And I choose. Sorry, the order was bad for this one. I choose two dependency injection frameworks. For the first one being GoWroc, I was looking for some for the most popular one, and it seems to be this one. Usage is quite simple. To what I show you on the previous slide is that we first create a container and populate it with so-called providers. Providers are the functions, the constructor that will create given type of dependency, and then we can invoke. In this example, I invoked a function that requires HTTP handler. So the container knows that, or try to find a function that will create this kind of type and returns it to me. This solution based on reflection, and we know reflection is not good, not so good idea. But the code itself seems to be pretty good and pretty clever, because if you make a mistake, it will tell you that either given dependency doesn't exist at all, or give you a hint that you should use this dependency instead of different. Because I tried to replace switch concrete type with switch interface with concrete type, and it gives me this information. And what's most important here is that constructors and arguments require exactly the same type. So if I return a structure, the same structure needs to be passed to other constructors, which seems to be a contradiction with this Go proverb: return structs, accept interfaces, and have this small bit of coupling. But probably this is the price for the for frameworks like this. And the last one, Google Wire. And Google Wire is hyped recently because this one uses code generation and not reflection to build all this dependency tree. At the beginning, I will say that this same limitation that the returned types and arguments must be the same type. And the usage, sorry, the usage of Google Wire is quite different because in the first place we have to create a wire Go where we register our dependencies, then run a wire command that will create a similar file with the same signature as this as found in the wire Go, which will be used later on in our application. And what we can find there is it just builds the tree of all the dependencies, and it will look like almost the same as in previous example mine Go. More or less, we will find there something similar to this. And in this example, all the dependencies, checking if we have everything in correct in order, will be shown to us, reported to us during this wire command. So, the advantages of injection dependency, in summary, is everything is coupled. It's easier to test, as I hope we present to you. Easy to change dependency, and overall, it's better maintainability. And one important quote I found about dependency injection is that dependency injections favor pluggable architecture. So as long as the bricks fit onto each other, we can simply switch them as we want, as it's required. So, thank you.